Hi everyone. In this video, we're going to work out this homework problem. For part A, we will set up an iterated integral in polar coordinates for the volume of the solid under the surface and above the region D. D is this region in the XY plane. This is the surface we're looking at. And then for part B, we're actually going to proceed with the integration and evaluate what it is. So for polar coordinates, you need to remember that the volume of a double integral over the region D of some function f of x comma y dA, this is going to be the double integral over the region D, where D you're going to express in polar coordinates, meaning r theta. Then you'll have your function written in terms of r and theta, where x is going to be r cosine theta, y is going to be replaced with r sine theta, and dA in polar coordinates, we like to use, so this is times r dr d theta. So this is your replacement of dA in polar coordinates. Now let's figure out what are our bounds for r and theta. So we know our region D, we're going to describe in terms of r and theta, and we need to know what are the restriction on r and what are the restriction on theta. So if you don't see that immediately from this picture right here, you can kind of try to draw that in the XY plane. So here's the view of this in R2. So this is a circle. We're just looking at 1/4 of the circle, this circle right here of radius 2. So if I were to label these points, this is 2, this is 2, this is the region D. Let's go ahead and shade this in. So that's the equivalent of what you see in the given picture. I just draw it in 2 dimensions. So R is the distance from here to here, that's R. So it's going to go from 0 to 2. So that's our radius, 0 to 2. And then theta is the starting point of the region from the positive x-axis all the way to here. That is going to be pi over 2. So theta will go from 0 to pi over 2. So that is how we're going to describe this region in polar coordinates. So that means our volume is going to be set up in the following way. So the volume is going to be the double integral. The inner integral is going to be r, bound on r. R is going from 0 to 2. The outer integral is the bound on theta. That's from 0 to pi over 2. And here we put in our function 1 plus xy. That is the surface. Now you have to express each of these in terms of r and theta. So we know x is r cosine theta, y is r sine theta. I'm going to replace them right here in polar form. So you have 1 plus r cosine theta, r sine theta. And then dA, we said is going to be this right here, r dr d theta. So that's r dr d theta. Okay, now let's simplify this, but pretty much that is the answer to part A. Set up an iterated integral, and that's what we have done in polar coordinates. Now let's evaluate this integral. Evaluating is actually very straightforward. So our volume is going to be, let's rewrite, this is 0 to pi over 2, then the inner integral from 0 to 2. Here, I will go ahead and distribute the r out, and then I'll also combine these two r's. So you'll have r plus r cubed cosine theta sine theta dr d theta. All right, so let's proceed with the integration. So first we're going to do the inner integral. This is going to be respect to r. So let's rewrite the outer integral. This is from 0 to pi over 2. If I integrate r respect to r, that's r squared over 2 plus then the next term. If I integrate this respect to r, cosine theta, sine theta, they're treated as a constant. So you'll have r to the 4 over 4. Rewrite the rest. And now we're going to evaluate this from 0 to 2. Then we finally integrate respect to theta. All right, so let's plug in the upper limit, replace 2 in place of each r. So we have the integral from 0 to pi over 2 of, so if I plug in r, I'm going to, r equals 2, I get 2 plus, so we'll have, let's see, this is going to be 2 squared That's 4, and then another 2, so that's 4, 16 over 4. That's going to be 4 cosine theta, sine theta. All right, and now we can integrate respect to theta. So when you integrate to respect to theta, that's 2 theta. Now for this, when you integrate respect to theta, you need a tiny u substitution. So I'm going to let u to be, I'll do u to be sine, then du is cosine theta d theta. So it's a nice fit. So we know this eventually becomes the integral of u respect to du, so it'll be u squared over 2, and then I substitute u back into the final result, so that will be 4 over 2 times u squared, so that would be sine squared theta. And then we evaluate each of these from 0 to pi over 2. All right, so I hope you were able to follow me as I did the u substitution and carry out the integration. Okay, so now let's simplify this. So I plug in the upper limit of integration, 2 times pi over 2. When you plug in 0, it's going to be 0. Plus 4 over 2, that's a 2. And then I substitute sine of pi over 2 squared, and the sine of 0 is 0. So the lower limit is 0. And then this will evaluate to pi plus sine of pi over 2 is 1. So pi plus 2. All right, there you have it. Our answer simplifies to pi plus pi over 2. So the volume of this solid over this region, it's going to be pi plus 2. All right, that's it. I hope this makes sense. I will see you next time. Take care, everyone.